All right, sorry y'all, I got cut off, and it was also really hard to see, so I'm zoomed in, and now we can see what's going on actually here. Okay, so sorry about that. All right, so in this case, let's try this again. All right, we're looking at the dotted line here. Clearly I couldn't see very well, so I apologize. This is the dotted line right here. Okay. Oh, I have to change the view. I have to see it in print layout. Oh, that's why I can't zoom in. That's terrible. Let's see if I zoom in. This is a major problem. Okay. Well, I guess that's the best it's going to be. So if we look at this, it's the dotted line. All right. So that would be the one that has the less than or the greater than symbol. All right. And so if I change it to draw, I'm going to go ahead and erase this here so I have some space. Look at that. It's actually, this is a 5. It's really hard to see. So the number under that where the y-intercept is 4. So this would be a situation in which our y-intercept is 4 and it's shaded to the left. So let's take a look at what our options are here. All right, so for this one right here, this would have a negative slope. The y-intercept would be 4 and it would be greater than. So if I were to plug in 0, 0, which is a side that works because it's shaded, it would say 0 is greater than 4. That is not true. So we can eliminate A because it doesn't work based on what we know. All right. Looking at B, which is bolded and actually is correct, we are looking at 2x. This one is where the less than sign is. So 2x plus y is less than 4. If I put this into slope-intercept form, we have y is less than negative 2x plus 4. So there we have a y-intercept of 4, and it's going down 2 over 1. And if I test 0, 0 here, which is in the shaded area, 0 is less than 4 is true. So that does mean that this side would be shaded, and that works for that equation. If we look at the first equation, this is not in slope-intercept form. It has the x and the y in the wrong place, okay? So we have x is greater than or equal to y plus 2. I would need to go ahead and subtract 2 from both sides, and I'll get x minus 2 is greater than or equal to y, or y is less than or equal to x minus 2. But here we have a y-intercept of 1. We're going up 1 over 1, and we should have a solid line, which we do. Testing a point here, if I test 0, 0, which is outside of the boundary, 0 is less than or equal to 0 minus 2. 0 is not less, let me do that again. 0 is less than or equal to 0 minus 2. So 0 is less than or equal to negative 2 is not true. 0 is not less than negative 2. So it would be this side that is shaded, which tells us that B is the correct answer. So if you have one where you have to match the graph with a given equation, you want to look for what the slope is of each line, whether it should be dotted or solid, and whether or not the shaded area actually works for that equation or inequality. If it works for that inequality, then it's true, and so then that graph does match. Looking at letter C, we have for the greater than or equal to, it would be 3x plus 2y is greater than or equal to negative 4. If we subtract 3x from both sides, we have 2y is greater than or equal to negative 3x minus 4. Divide both sides by 2. So here what would happen is for this greater than or equal to 1, we have a negative slope. And this line right here where we have the greater than or equal to line, because it's including a solid line, is not going to be a negative slope. It's a positive slope, all right? And so that's why C does not work, all right? Let's take a look at this one over here. All right, so if I'm looking at this one here, I need to figure out which graph is best represented. And I have two lines, one's dotted and one's solid again. So let's look at this dotted line here is starting again at 4, and it is a dotted line, so that would be our less than or greater than 1, all right? It looks like the orange area is the part that matches that inequality. So let's take a look at letter A. Letter A has y is greater than 4 minus x. It can be y is greater than negative x plus 4. So here it looks like both the slope and the y-intercept and the dotted line are correct for that. Let's see if the shading is correct. So one of the solutions is 0, 0. So 0 is greater than 0 plus 4 is not true though. So there's something wrong here potentially with our sign, because that orange shaded area does not work for this inequality. Let's take a look at the next one. So the next one we know actually you can eliminate because it's the same as this guy over here. But let's look at C then. So C has x plus y is less than 4. If we subtract x, we get y is less than negative x plus 4. So that's the opposite of here where it was greater than, which tells me that this right here does match this inequality right here. And let's double check the one with the greater than or equal to. So if we solve 3x plus 2y is greater than or equal to negative 4, subtract 3x from both sides, we get 2y is greater than or equal to negative 3x minus 4. Divide both sides by 2. We get y is greater than or equal to negative 3 over 2x minus 2. All right, so here we do have a minus 2y intercept. We're going down 1, 2, 3, and over 2, so that slope also works because it's a negative slope. We have a solid dotted line, so we need to see if that blue shaded area works. According to this, 0 should work. So 0 is greater than or equal to negative 3 over 2 times 0 is 0 minus 2. 0 is greater than negative 2, so C is our best answer. I circled that just to show you that that was on the same page, but C is our correct answer. All right. So again, if you are given a graph and you need to match the inequality, you want to look at 3 things. 1, the lines, is it dotted or solid? 2, your slope and y-intercept. And then 3, you want to test a point and make sure that the shaded area works, right? All right, these are fraction reminders. To divide a fraction, you multiply by the reciprocal or keep, change, flip. To multiply a fraction, you multiply straight across. To add or subtract a fraction, you have to find the common denominator. So let's start with this one right here. In this case, this is the same as, and I want to go over this, x over 4 is the same as 1/4 times x. It's the same thing, okay? There's an invisible 1 in front of that x, and so 1/4 x is the same as x over 4. And so in this case, I want to get the 4 out of the denominator, and the opposite of division is multiplication. So I'm going to multiply the whole thing by 4. This then becomes 4 over 4 is 1, so we're left with x. 4 times 2 is 8, and 4 times 10 is 40. So now you can easily solve that x equals 32. Here, again, I want to get rid of the 3 over 2. Before I do that, I'm actually going to add 1 to both sides, just so I have 3 over 2x equals 10. And then now I'm going to go ahead and get rid of 3 over 2. To do that, I'm dividing by 3 over 2. If I'm dividing by 3 over 2, I am multiplying by the reciprocal. So I'm multiplying the whole thing times 2 over 3. Then this becomes 2 over 3 times 3 over 2 is 1, so that's x equals. And then 2 times 10 is 20 divided by 3. All right, because you have to multiply this as well. Whatever you do to one side, you'll have to do the other side. All right, to multiply a fraction, you multiply straight across, so this is 2 over 12, or 1 over 6 if you want to simplify it. And then to find a common denominator, you want to find your least common multiple. So 3 and 2, the least common multiple is 6. So I'm going to put 6 in my denominator for both of these. And then what goes in my numerator, 6 divided by 3 is 2. And 6 divided by 2 is 3. 3 times 1 is 3. So now I can write this as 5/6. Same thing for here. My common denominator is 6. Right? Oh, sorry. The difference between this one is now I'm subtracting. So this is actually going to be a negative 1/6, not 1/3, 1/6. That denominator will stay the same. 2 minus 3 is negative 1. Okay? All right. Very quickly, I'm going to go over a quick fraction thing just to remind you. All right? If you have 2/3 x, for example, and you want to solve for x, right? you are dividing both sides by 2/3, which means that you are multiplying by the reciprocal. Sorry, there's apparently lots of fire engine action happening over here. The reason is this would be 6/6, which is just 1. And the purpose of that is we want to get a coefficient of x to be 1 because that's what allows x to be all by itself. So you want that coefficient of x to be 1, which is why we divide or multiply, because we want to make it 1. When we, for example, if we have 2x plus 3 equals 6, when we subtract this 3, the reason we subtract 3 from both sides is because we want this to be 0. 3 minus 3 is 0, which leaves only 2x. So you're not really eliminating it because the number that's invisible that's there is 0. All right? So when you're trying to figure out, do I subtract, do I multiply, what do I do? You're trying to think about what can get you a coefficient of 1 for x or y, and what can get your constant to be 0. How can you make this number without a variable 0? Okay? All right. More practice problems. So these practice problems are really important. They're going to help you a lot with the assessment tomorrow. So a student has a hair business. She charges $30 per hour for coloring and $20 per hour for cuts. You should have seen this above as well. Because she is in Miss Lee's class, it gets a lot of homework. She can only work at most 20 hours per week. She wants to make sure that she has jobs that allow her to practice both types. Her goal is to make at least $350 per week. What are the inequalities or equations that would apply in this situation? So what I suggested you do is you first start by writing your own, okay? And so if we have 30 per coloring plus 20 per cut, and she wants to make at least $350, that's one of my inequalities. And I see that one right here. This one right here is wrong because it says at least, which means she could make more, and this has a less than sign. All right, so that one's not it. The other one is 20 hours per week. So this x and y represent the number of hours she's working, so x plus y, and she can work at most because she's a student, so that has to be less than or equal to 20. So this is another one. So now we need to explore the other options up here. So x is greater than 0. Well, it does say she wants to make sure she has jobs that allow her to practice both types, which means she can't practice 0 of any type. She has to practice at least one of each type. And so that would mean that x has to be greater than 0. Y represents cuts, so y can't be less than 0. We can't have -1 haircuts. That would be weird. So this is not a possibility. And then x plus y equals 350. X is the number of hours and y is the number of hours. X is hours for coloring, y is hours for cuts, but I can't add hours and get money. That's not how that works, okay? The reason this works is because I'm multiplying money times hours, and so we're going to get money. But here, I can't add, 2 hours plus 3 hours is not going to equal dollars all of a sudden. All right, so that's why this one does not work. Number 2 says, which graph represents the system of inequalities? Explain your reasoning. So this is similar, right? This is similar to what I was talking about before. How do we match these up? All right, so let's start by looking at these both have a greater than or equal to sign, which means that they both need to have solid lines. There's only one that has solid lines. So that would be this one. That's the only one that both of them have solid lines. But the other thing to look at, right, if you were in a situation where they all had solid lines and you need to pick a graph, right, you're going to look at making this in slope-intercept form, which would be 3y is greater than or equal to -x plus 6. Divide both sides by 3, and we'll get y is greater than or equal to -1/3 x plus 6 divided by 3 is 2. Okay. Now again, this is -x over 3. That is the same as -1/3 x, so that will help you with your slope. All right, so you can check to make sure that that y-intercept, that slope, and that line, and then the shaded area work out and match. So here, that's this line right here. It's greater than or equal to, and the top part is shaded, because if we were to test 0, 0 here, 0 is not greater than 2, so we know that down here doesn't work. We would have to shade up here. so we know that matches. So again, look first for your dotted and solid lines, and then you can eliminate options and determine which one works best.